Exercise 1.1, question number 3, Roman 13, y equal to log of root of 1 minus cos 3x upon 1 plus cos 3x. That is, log of root means raised to 1 half. Now we know the property as log of a raised to p is always equal to p log a. Therefore, this half will come down and it will become half log of 1 minus cos 3x upon 1 plus cos 3x. This is of the type log of a by b. Log of a by b is always equal to log a minus log b. Therefore, this will become half as it is log of 1 minus cos 3x minus log of 1 plus cos 3x. Now the function becomes easier and we can differentiate it with respect to x. 1 half as it is, derivative of log of something 1 upon that thing. So it will be 1 upon 1 minus cos 3x. Derivative of cos 3x is minus sin 3x and derivative of this 3x is 3. Here also derivative of log of something 1 upon that thing, derivative of cos 3x minus sin 3x and derivative of 3x is 3. This 3 sin 3x and this 3 sin 3x is common. So we can take it out. 3 sin 3x 1 half as it is. What remains here is 1 upon 1 minus cos 3x plus this minus and this minus. Minus into minus will give you plus, no? So 1 upon 1 plus cos 3x. This 3 sin 3x is common. It is outside the bracket. Now we can cross multiply 1 plus cos 3x plus 1 minus cos 3x upon 1 minus cos 3x into 1 plus cos 3x. This plus cos 3x will get cancelled with this minus cos 3x. 1 plus 1 will become 2. Now a minus b into a plus b is always equal to a square. 1 square is 1. A square minus b square. So 1 minus cos square is always equal to sin square. This 3 sin 3x as it is, this 2 and this 2 will get cancelled. So sin 3x once again will get cancelled. What remains is 3 upon sin 3x. But 1 upon sin 3x is always equal to cosec 3x. So answer is 3 times cosec of 3x. Roman 14 it is log of root of something. Log of this bracket raised to half, I will say. Half will come down, log of the bracket equal to half this log of a upon b. See here, log of a upon b is always equal to log a minus log b. Differentiating with respect to x, what we will have? 1 half log of something 1 upon that thing. Derivative of cos is minus sin and 5x by 2, derivative of that is 5 by 2 minus log of something 1 upon that thing and derivative of cos is minus sin 5x by 2 and derivative of 5x by 2 is always 5 by 2 because derivative of x is 1. Now what we can take out common as this minus 5 by 2, this minus 5 by 2 sin 5x by 2. Okay. What remains behind is 1 upon 1 plus cos 5x by 2. As this minus we have taken it out, this minus and minus, this will become plus. What remains is 1 upon 1 minus cos 5x because this 5 by 2 sin 5x by 2 is common. Okay. Now 1 half as it is, minus 5 by 2 as it is, sin 5x by 2 as it is. We will cross multiply. So 1 minus cos plus 1 plus cos upon a plus b into a minus b will give you a square minus b square. That means 1 square minus this cos square. In the numerator, minus cos plus cos will get cancelled. 1 plus 1 is 2. 1 minus cos square is always equal to sin square. Now this 2 and this 2 will get cancelled. This sin pi x by 2 and this sin pi x by 2 will get cancelled. This Sin 5x by 2 in the denominator will be in the numerator as cosec of 5x by 2, because 1 upon sin is always equal to cosec. This 2 and 2 will get cancelled. What remains is minus 5 by 2 cosec of 5x by 2. Roman 15, y equal to log of root. Log of bracket raised to half, that is. This half will come down. See the property once again. Log of a raised to p is always equal to p log a. Here also same thing. Log of bracket raised to half is half log of that bracket. Log of a by b. See once again that property. Log of a by b is always equal to log a minus log b. So this thing will become log of 1 minus sin x minus log of 1 plus sin x. See here. Now we can differentiate easily. 1/2 as it is, log of something 1 upon that thing, and derivative of sin x is always cos x. Minus sin is as it is. Minus log of something 1 upon that thing, and derivative of sin is cos x. See here once again, log of something 1 upon that thing. This minus sin as it is, derivative of sin is cos, minus sin, derivative of log of something 1 upon that thing, that means log of 1 plus sin x will become 1 upon 1 plus sin x, and derivative of 1 is 0, derivative of sin is cos of x. We can take out common cos of x. What remains here is minus 1 upon 1 minus sin x, and here minus 1 upon 1 plus sin x. This cos x will go out of the bracket. Now we will cross multiply. Cross multiplication will give you minus 1 minus sin minus this minus 1 minus into minus will become plus sin. Sin x will get cancelled. Minus 1 will become minus 2. 1 minus sin square, how it comes? This is a plus b into a minus b. It is a square minus b square. So 1 minus sin square is cos square. Cos x will get cancelled. 2 upon cos is always equal to sec, or 1 upon cos is always equal to sec. This 2 and this 2 will get cancelled. What remains here is minus 1 upon cos. 1 upon cos is sec of x. Hence the answer. Roman 16, y equal to log of 4 raised to x in bracket x square plus 5 upon root of 2x cube minus 4 raised to 3 by 2. We know that log of a into b is always equal to log a plus log b. So multiplication of the functions, log of that is addition of the logarithms. Now here log of a by b, it will become, first of all we have to treat this 3 by 2. So log of bracket raised to 3 by 2. 3 by 2 will come down. Okay. Now log of a by b is nothing but log a minus log b. Okay. Now 3 by 2 as it is, log of x square plus 5 also as it is, minus this power half will come down, log of 2x cube minus 4. So function is simplified now. See here, directly also we can tell that log of 4 raised to 2x plus log of this bracket raised to 3 by 2. For next step, this 3 by 2 will come down, and inside the bracket log of x square plus half minus log of this 2x cube minus 4 raised to half. For next step, that raised to half will come down. Okay. See here, this is the final simplification for the function. Now we can differentiate easily. Log 2 log 4 is the constant thing. Derivative of x is 1. 3 by 2 as it is. Log of something 1 upon that thing. That log of x square plus 5 is 1 upon x square plus 5. Derivative of x square is 2x minus half as it is, log of something 1 upon that thing. Now 2x cube, derivative of that is 3 into 2 will become 6 x raised to 2. This power will get decreased by 1. Okay. Now final answer is 2 log 4. This 2 and 2 will get cancelled. Therefore 3x upon x square plus 5. Here it is this 2 and this 6. 2 can divide we can divide by 2 to this 6. 2 3s are 6, 3 3s are 9, 9 by 2 it is 9 by 2 x square upon 2x cube minus 4. Next question is Roman 17, y equal to log of the bracket. So first of all, we will say that this is of the type log of a by b. It will become log of a minus log of b. Now here inside this bracket, the function is of the type log of a into b. Then it will be log of a plus log of b. Log of 7 minus 6x raised to 1 by 3. That is log of a raised to p. It is p log a. That means 1 by 3 will come down. Same thing here, log of a raised to p. It will become p log a. That is x square will come down. Here also this 3 by 2 will come down. And 1 by 3 log of 7 minus 6x as it is. Here base is not mentioned, that is base should be e here. We know the property that log a to the base a is always equal to 1. So function is x square plus 3 by 2 log of 5 minus 4x minus 1 by 3 log of 7 minus 6x. Differentiating with respect to x, we will get derivative of x square as 2x, 3 by 2 as it is, derivative of log of something 1 upon that thing, derivative of 5 is 0, derivative of minus 4x is minus 4. Here it is 1 by 3, derivative of log of something 1 upon that thing. That means log of 7 minus 6x will be 1 upon 7 minus 6x. Derivative of constant is 0. Derivative of minus 6x is minus 6. Now we can have it as 2x. 2 2s are 4 and 2 3s are 6. This minus sign will appear here. 6 upon 5 minus 4x. This minus and minus will become plus. 3 1s are 3 2s are 2 upon 7 minus 6x. Question number Roman 18, y equal to log of this bracket. This is of the type log of a by b. That means log of a minus log of b it should be. Now the function is of the type log of a raised to p. It will be p times log of a. That means log of a raised to cos x will give you cos x log of a minus, inside the bracket there is a multiplication of the functions. So we should add the functions in the logarithm. Log of ab is always equal to log of a plus log of b. This minus sign will go inside and this log of a raised to p will become p log a. That means log of x square minus 3 raised to 3 will become 3 log x square minus 3. Now we can differentiate easily. Log a is the constant thing. Derivative of cos is minus sign. Minus 3 as it is. Derivative of log of something 1 upon that thing. That means log of x square minus 3 will become 1 upon x square minus 3. Derivative of x square is 2x. Derivative of 3 constant it is 0. Minus derivative of log of something 1 upon that thing. That means derivative of log of x 1 upon log of x. Derivative of log of x 1 upon x. Now simplified form is minus sin x log of a. These 3 2s are 6 upon x square minus 3 as it is. Here it is 1 1s are 1. In the denominator it is x log of x. Next question number 19, y equal to 25 raised to log of sec x to the base 5 and 16 raised to log of 10x to the base 4. For this base 5, I will also transform this 25 in as 5 square as the base 5. So 25 is 5 square. Similarly, 16 is 4 square. Here it is power raised to power. Then it is product of the powers. It will become 2 log of sec x. See here. Here it will become 2 log of tan x. Now this 2 will go up. That is a log p is always equal to log of p raised to a. So it will become 5 raised to log of sec square x to the base 5 minus, as this 2 will go up, the function will be 5 raised to log of tan square to the base 4. Now we know the property that a raised to log of p to the base a is always equal to p. Similarly, a raised to log of p to the base a is always equal to p. The function gets simplified as sec square minus tan square, that is equal to 1. Okay. Sec square minus tan square is always equal to 1. Differentiating with respect to x, derivative of 1 is always 0. Now, question number 20. It is of the type u by v, then v du by dx minus u dv by dx upon v square. That means denominator as it is, derivative of the numerator, minus numerator as it is, derivative of the denominator upon denominator square. Derivative of bracket raised to 4, that means 4 bracket raised to 3 it will be. Derivative of x square, it is 2x. Derivative of constant 2 is 0. Is x square plus 2 raised to 4 as it is. Derivative of root 1 upon 2 root, and this derivative of x square is 2x. This 2 and 2 will get cancelled. Now to simplify the function, we will multiply the numerator and denominator by this root of x square minus 5. So the function will become, the differentiation or derivative will become x square minus 5. 2 4s are 8x, this bracket raised to 3, x square plus 2 raised to 4 into x upon x square minus 5. Okay, let us see. So yes, it is the same simplification. Now once again let us see. If we are multiplying the numerator and denominator by root of x square minus 5, what we will get here? Root into root, the root will vanish here, x square minus 5, 4 2s are 8x, x square plus 2 raised to 3 minus x square plus 2 raised to 4, this root will get cancelled, x upon x square minus 5 into root of x square minus 5, because we are multiplying the numerator and denominator by root of x square minus 5. See here. Now we can take out x square plus 2 raised to 3. Here it is raised to 4 and here it is raised to 3. We can take out x square plus 2 raised to 3. Also this x we can take it out. What remains behind is 8 times x square minus 5 minus, as raised to 3 is common, we do have raised to 4 here. So what remains behind is x square plus 2. This 8x square minus this 1x square will give you 7x square. 8 5s are 40 minus 40 minus 2 will give you minus 42. It is x square it is. Okay. 8x square minus this x square will give you 7x square. 8 5s are 40 minus 40 minus 2 will give you minus 42. Root into bracket. That means a into root a is always a raised to 3 by 2. Okay. Now next question is the values of the function are given here. So we have to get the derivative of that. Here r of x is f of g of x, then r dash of x will be f dash of g of x into derivative of this g of x. That means f dash of g of x into g dash of x. We want r dash of 2 here. R dash of 2 will give you f dash of g of 2, okay, into g dash of 2. What is g of 2 here? See, g of x and this is 2. So g of 2 is 6. So here we will put 6. G dash of 2. See g dash of 2 is 4. Okay. So we will put here 4. Now as we have put here g of 2 as 6, we have f dash of 6 here. So f dash of 6 is minus 4. Okay. F dash of 6 is minus 4. This minus 4 into 4 will give you minus 16. Next thing, r of x as g of 3 plus f of x. Then r dash of x will give you g dash of 3 plus f of x. Now derivative of this inner function, that is derivative of 3 plus f of x, g dash of this bracket as it is, derivative of constant is always 0, that is derivative of 3 will be 0, derivative of f of x, f dash of x. Now g dash as it is, this 3 as it is. Now f of x, as we want r dash of 4, we will place here f of 4. We want r dash of 4, no? Then we should have here f of 4. F of 4 is given as 3. Okay. As it is f dash of x here, we want r dash of 4. We will put here f dash of 4. F dash of 4 is 5 here. This 3 and this 3 will give you 6. We want g dash of 6 now into 5 as it is. G dash of 6. G dash of 6. That's the last thing is 7. 7 5s are 35. Next thing, s of x is given as s dash of x, f dash of that inner bracket, derivative of the inner bracket, derivative of constant 9 is 0, minus this f dash of x. Now, we want s dash of 4. Then s dash of 4 will be f of 9 minus f of 4 into this f dash of 4. F of 4 is given as 3. So 9 minus 3 will give you 6. So we want to have f dash of 6 here. And f dash of 4, see f dash of 4 is 5.